Thing. Let's announce that we are live. You know what's crazy is how Discord adds the exclamation point to the URL. I mean, it makes sense. It's a valid part of a URL, but it's just crazy. No one like types that in a message. But I guess it makes sense. All right. Anyways, we are Discord adds the exclamation point to the URL. We are live. Let me mute myself. My time delayed self. That was very disorienting. Cool. Let's give people a couple minutes to come in while I eat this baby bell, and then we'll get started. How's everyone doing? Yeah, that's right. Time to get decimated by chows. Am I feeling any better? That's a great question. Right this moment, I feel great. You get this adrenaline rush when you start teaching, but man, ever since 2 days ago, basically, I have had zero energy. It's been insane. I don't understand why. Just having a hard time kicking this cold, and it's bad news because I needed to finish writing a grant proposal by today, but it's not done yet, and then I have to probably stay up all night working on it, and that's gonna make me even more tired, and it's a vicious cycle. I wasn't diagnosed with shit. I mean, I wasn't diagnosed with anything. To answer a question on Twitch, I took a million negative COVID tests, and my doctor just said, "Yep, it sounds like an upper respiratory infection. You just have to." I think it just your body gets out of practice. 2 years of not getting sick. Let's see. Alright, people on Twitch are answering this question on Twitch, how to check each bit in a byte. That's right, shift right and ending with hex 1. So you have a bit, a byte, and you shift it so the bit you're interested in is on the very right. And then when you end it with a 1, it just keeps only that bit, and then you're good to go. That's good stuff. Alright. Are both GDB chows and reverse engineering chows launching today? Yes, absolutely. Connor is furiously getting them ready. They'll be launching. Could you also divide by 2 and check remainder, or modulo 2, or yeah? There's a lot of stuff, a lot of good stuff. You can also avoid the shift if you just and with the correct bit mask, like OX80 for the leftmost byte. Let's see. Okay, let's get started. Furiously ready, getting them ready a while ago. They're ready. Good. They're ready. Deadline for both will be covered in the slides. Let's roll into the slides. I forgot to bring them up beforehand, so sorry about that. Here we go. Slides, presenter view. All right, we are in week 5.5, which is exciting. We're a third of the way through the semester. That means we are getting, of course, there's a much wider ramp up with Embryo IO and so forth this year, but we're getting closer and closer. It's gonna be pretty exciting. Is there anywhere we can find the full class schedule online? I guess it's in these videos. It'll be in a couple of slides. We can probably what we should do is post a link to these slides somewhere, because I think right now the only people that have a link to these slides are the people that sniff them out of like an accidental stream snafu where the URL was showing. Yeah, I think these slides would be great. Okay, let's roll on. So I figured we'll do the meme review first, and then we'll just roll on straight through the material launching, and then the in-person component. You might have noticed that the GDB video never went up yesterday. I didn't have the energy for it. We'll do GDB live, and then I'll record a video for it afterwards. So it'll be in this video. All right. So, apparently this stream is streamable in 480p. That's really interesting. I didn't do anything special for that. I think it's just up to Twitch's direction. Yeah. Wow, you can stream this in 160p. That's fun. All right. Cool. Interesting. Okay. Anyway, so let's roll onwards. The meme review. This time we had several different meme genres as before. So this first meme genre, I kind of mixed together kind of general pwn.college memeing and PyPy OP. And of course, HK Re is the new top dog. So it's going to be really interesting to see what happens week 2. No pressure on anybody. You know, it's totally fine being in 23rd. If you look, let's see where Zardus is on the dojo scoreboard, because that's important to see. If you search for Zardus, not even on here. That's how low I am. I'm like, whoa, Connor, do we really have exactly 512 people that have scored, or is this wow, exactly 512. All right, well, let's close down pwn.college to new users. 512 is, or 512 new users come in at once. Anyways, so I haven't scored shit. So if you've scored anything, you're beating me in terms of grades. So good job. And of course, we'll come back to this. This is a bit of a foreshadowing of several slides in. People are making memes instead of solving chals, it seems, but that's life, you know. All right. Hey, Zero dropped into the chat. Welcome back. All right. Another genre is baby jail. Just all sorts of baby jail with a large contingent of people making memes about being unable to escape from these damn jails, right? The presence of the fake flag is rather controversial. People have asked before, what's the pedagogical value of having a fake flag in this jail, right? It just confuses people. But it also, part of learning is pain. You know, pain is the uncertainty leaving your body. And it's just a little bit, boom, boom, fake flag. Fake flag for you. All right. Exactly. So, what have we got? We got a lot of people abusing this solutions to later baby jails to solve earlier baby jails. It's unavoidable in a way. A lot of the challenges try to build up an increasing complexity, and that means if you solve a very complex problem, of course, that has implications toward earlier solutions. I hope people have looked at you know, using nanosleep, et cetera, because that's useful. And if we have time for the advanced what's it called, speculative execution vulnerabilities, stuff like that, the microarchitectural module, it will be very relevant. But you know, we'll see if that module survives contact with the schedule. Of course, if you use nanosleep in a very you know, simple way, you just sleep for some amount of seconds, which that amount of seconds is the value of the flag. You'll be waiting for a long time. We ran an accelerated pwn.college workshop over the summer in 3 weeks, 8 hours a day, with us and the students being there. We ran people through the entire curriculum, all of the modules, and that, when it's that accelerated, a naive level 11 script is pretty bad news. Yeah, it's pretty good stuff. Yeah, and so, of course, on Twitch, someone mentioned binary search for the win. Exactly. Binary search or other optimized methods, leaking 1 bit at a time instead of 1 byte at a time, right? So you only have to sleep for 1 or 2 seconds per bit times 8, which is about, let's say, worst case, 20 seconds per byte. You can leak it a lot faster than possibly waiting up to 256 seconds per byte, or other optimizations. So, and of course, the binary search is equivalent to leaking out byte by byte or bit by bit, because the binary search leaks out bit by bit from the most significant bits. All right, very, very cool stuff. Also, I was very impressed actually with the insanely wide variety of ways that people found to solve level 12. Level 12 is the one that doesn't give you any syscalls other than read, right? And of course, our solution uses the side channel of we either crash or we loop forever, right? So we hang or we crash. But there's so many. Some people figured out that you can create a pipe, or rather, you can open some. I'm trying to remember how this works. You open a file that you control that has a cyclic pattern or whatever, or just A, B, C, D, and then you read. You pass that into your program that you launch. You read the number of bytes from that file that corresponds to the byte that you're leaking from the flag, and then in your parent, you read the next byte and you see what it is. That's brilliant. I hadn't thought about that. There were solutions proposed in the Discord that people were brainstorming that had to do with exhausting the entropy of the system as a signal, which is of course overkill, but or taking up memory. You could have something that takes up all of the allocates the whole stack by just pushing a bunch, right? Which is measurable from the outside world. It's very cool stuff. Yeah. Oh yeah, and Connor said in the chat, our solution just is actually updated to increase the speed of the so we probably crash different. Yeah, so it's very cool stuff. There's a lot of different solutions, and I really hope we get to that microarchitectural flaws module, because there will be a lot of very interesting stuff to explore there. All right, third genre of memes is basically baby rev is coming. So this one is great. I've never seen this third panel of this meme. It's hilarious. You can make it to the yellow belt. The thing is, baby rev is gonna feel like a punch in the face sometimes, right? But then afterwards, you look back from the viewpoint of having tackled toddler 1 a couple of weeks later, and it'll seem so simple. That's the beauty, I think, of this course. When people start looking back at earlier material that was super hard, by the end of this, you have the 180 levels of embryo IO, or the shell coding levels. You look back at it like, oh, this is trivial. Why was this hard? Because that's where we'll have it pro up. Question of whether or not I'll teach 468. Is that networking? It would be interesting to make a couple of a networking like pwn.college. Hadn't thought about it yet. There's teaching doing a good job teaching takes a lot of time. Even doing a bad job teaching takes a shocking amount of time. And so at that point, you might as well do a good job, and if you're gonna spend time anyways. But yeah, it'll be very interesting. Yeah, no, there's not 180 levels of embryo GDB. There's 7 levels of embryo GDB. You just want to make sure that you have exposure to having used GDB so that you have the confidence that you can use GDB and the awareness of the type of things that you can do in GDB, because it's very useful for reverse engineering and it's very underused. The amount of challenges this year for Baby Rev is more than last year because, of course, more challenges doesn't mean it's harder. The hardest challenges aren't harder. It's just we filled in the middle to try to avoid the massive kind of, what's the term? Not die off, but you get what I mean. A lot of people solved up to like level 9, and then there was a massive fall off of students. But we're making it better. The massive cliff. Thank you. Great cliff. All right. Oh shit, hold on. I need to very quickly reconfigure my there we go. Okay. Sorry, I had to very quickly reconfigure my OBS for desktop audio. For some reason it had gone away. All right. So that's this meme, but of course, remember, Baby Rev is coming, and there's not going to be any source code this time. Connor, did you remember to remove the source code? I hope he did. Good. All right. Final category. Actually, not final. Third category is the multiple aspects of Jan. ASCII Jan, big fan of that. In the Discord, there's also Pasta Jan. Didn't make it to these slides, but that was pretty good. The ASCII Jan is real, but even ASCII Jan is proud of you when you solve Chals. And you know what? I am right about MIPS, no matter what this meme template might imply. Speaking of MIPS, I'd like to take this opportunity to call for reasonable architectures in cybersecurity and computer science education. There's no reason to learn MIPS. All of these assembly computer organization courses that teach MIPS, they are not teaching the right architecture. You know, if you want to work with MIPS, get an old router. Even nowadays, many routers are switching to ARM. If you're teaching ARM, okay, that's fine. It makes me sad because ARM is painful to look at and interact with, and just painful to live in a world with ARM, the architecture. But at least don't teach MIPS. I mean, the only modern machine that I could find other than like routers, some routers that runs MIPS is like the Tesla, which sure, that's impressive, but still, you know. All right. There's a student making an x86 course for their thesis. That's interesting. Yeah, TLDR, MIPS bad. Okay, the last meme. Didn't play any video memes last class because because we get copyright struck when we play video memes. I'm gonna play this one. It's just too good not to play. I'm gonna listen to it on my own thing. It's just too good. Let's see. But in the recording of this, almost certainly YouTube is gonna slice out the next couple of minutes of this meme running. But here we go. This is amazing. Amazing. That was incredible. The one thing that I was thinking would be amazing if a yellow box popped up right at the end there. That would have been good. Who did that? Let me check who did that. Who did that? Hold on. There was a baby fall just now and crying. I'll be right back. 1 second. All right, we're back. Sorry about that. The baby Jan has learned to stand up off her potty, and then she somehow managed to flip over and fall headfirst into her potty. But that's up to my poor wife to sort out. All right. Anyways, let's scroll up. Where's the? I'm almost there. I'm almost to the memes. Oh my god, there's a lot of memes. There's a lot of memes. No, where is it? I don't see it. Did we figure out who Oh yeah, it was Thanks. Thanks made that meme. Great job, Thanks. I think Thanks is... Oh man, there's a part 2? Oh. That was nice. Hopefully there will be a part 2. Okay. Good job, Thanks. Ah, it's in the main meme channel, not the ASU meme channel. Awesome. Yeah, Thanks. You're a yellow... No, you're not a yellow belt. Okay. I'm colorblind, so I actually missaw the color. You're an ASU student. Awesome. All right. Great job. Thanks. So, this meme and then all of the other, like, really incredible memes have gotten us thinking that...
Do you want to know?
No. How do I go through it? Have gotten us thinking that you're not spending enough time solving chals, you're making memes instead, and this is impacting your grades. So, but we know you're not going to stop making memes because they're pretty good. So we're going to introduce an extra credit category for memes. There's about 10 weeks to the end of the class. Every week, you can get half a percentage point to your final score if Connor or I emoji react to your pwn.college meme on the meme channel, either of the meme channels in the Discord. We're going to do our best to stay on top of things and of course, make the meme good. We're not going to react to low-effort memes. It's going to be pretty good stuff. Gonna have to be pretty good stuff. So this is what I made to start things off. I think it's an okay meme. We're only gonna react to one meme of the car going off the road for making memes rather than solving chals. So don't go insane with that one. Are there retroactive points? I think we'll start out with not having retroactive points because there's all sorts of like fairness issues, you know, and so forth. But we'll hopefully this will be good. There's like 5% extra credit available through the end of the class, so it'll be pretty good. All right. What does this mean? This means that the grading has been updated. So now there is your grade is your average of your modules grade, plus the TTF extra credit, plus the help extra credit, plus the bug extra credit, plus the meme extra credit. Awesome. All right. So yes, this is real. Looking forward to the memes. My my teaching theory conception of this is that making memes around the material, especially, you know, digging in like the you know, Baby J level 11 memes, stuff like that, it keeps you thinking about that material, keeps you engaged with that material. I think maybe this is the future. I was telling Connor, because of course we're very concerned with being hip and fully up to date with all of the latest developments. So I was telling Connor, maybe this is the future. Maybe in the future everything else will be extra credit. The memes will be your actual score. Negative points for MIPS memes, unless they're dissing MIPS, then it's fine. All right. Yeah, so Jason saying one of the memes actually caused me to think more, and I got the solution. All right. Awesome stuff. So you might, by posting a meme, you might get the meme extra credit and the helpfulness extra credit if someone thanks you. That's pretty good. All right. Yeah, extra credit for that glorious Matrix meme. Maybe we'll think about it for the retroactive stuff, but for the future, for sure, a lot of good memes hopefully will be singing around. All right, let's take a look at the scoreboard. The scoreboard hasn't changed since Tuesday because, well, at least the top 20, because the top 20 have already been claimed. So, of course, the big winner this week is H. Cree. Well, I'm not going to pronounce that properly, but I'm sure there's a good pronunciation. And then number 2, Buby, 3, PyPy62, 4, renamed, 5, Owl A. Great job. So there's some ASU students, of course, pushing to the top, and then there's an enormous invasion of worldwide students. So ASU students, come on, let's find them out. But if you, at this point, the top 41 have solved everything available until shortly when Connor will launch the new chows. All right. CTF extra credit. Don't forget, this weekend there are 4 CTFs that you can play. And I'm going to add one more, at least for this weekend. It's not a CTF, but it's a brand new war game, Deus Ex 64. A brand new war games from the creators of hacking training platform called War Games. Deus Ex 64 is a series, as this website says, of increasingly difficult computer security challenges pertaining to reverse engineering and binary exploitation. All right, so if you can tackle this one, I'm gonna waive the team requirement because this is a personal thing. Just this weekend, if you can tackle this or want to tackle this as a CTF, spend 8 hours on it or several flags, and then let me know what you think. So this is by our friends at Red 2 Systems. They're a bunch of super elite hackers, very, very good people. So that you can make a write-up for in addition to or instead of a traditional CTF this weekend. Otherwise, for traditional CTFs, these are the CTFs that you can tackle. So someone is asking, so is Deus Ex 64 a CTF? No, it's more like pwn.college. It's a bunch of challenges. Yeah, I'd have to register. I don't have a War Games account, but if you create an account, register, you'll see. It's basically just like a set of challenges of progressing difficulty around 64, AMD 64, presumably based on the name, reversing an exploitation. So it should be pretty cool. All right. Just for this weekend, again, I really want people to get familiar with CTFs, but for this weekend, since Deus Ex 64 just launched, let's make an exception. All right. So let's take a quick look at helpfulness. I was looking at the kind of epic battle, at least between second and third place here, and then I noticed that someone else is coming up close to third place. So now there's 4 people that I'm going to be reporting on for helpfulness. A great job. We'll try to get somewhere around the launch of Toddler 1, maybe we'll try to get a better idea for you of the current helpfulness, how this, I need to move my face, boom, how this actually translates to your grades, but it's pretty good. Yeah, so Ethan, don't stop thinking PyPy. Maybe PyPy deserves the number 1. There's number 2 is a very hallowed position as well. I got second place many times in my life. It's kind of like, my thing. All right, awesome. the schedule. Someone asked about the schedule. Here it is. We are in the middle of September. We're launching the reverse engineering module. This module will be live for 3 classes, 1.5 weeks. And memory corruption will launch on the 28th. The reverse engineering module is going to teach you how to reverse engineer code. Historically, it's been a little bit of a tough module, but I think this is going to be very good. It gives you 2 weekends to and many office hours, classes, etc., to get pro'd up on reverse engineering. That'll be good stuff. So, how did people do on Baby Jail now that it's over? People did, let's say, better on the low end and worse on the high end than Baby Shell. Baby Shell had this very big split for some reason. Either a lot of people did quite well or not so well. Baby Jail was much more spread out, which is very interesting to see. Another view of it was Baby Jail had less A+, fewer A+, fewer A's. But is the Deus Ex thing playing music? Sorry about that. Yeah, that was Deus Ex playing music. Their website plays music. Oh shit! Oh no, I just did a very bad thing. I just closed the browser window. Oh my god! Hold on. This is a bad news. I have to fix this real quick. Oh my god. Okay. That's back. But is it going to work? No, it's not going to work. Oh my god. Okay, we're back. Phew. OBS is my arch nemesis, guys. It's insane. It's harder than binary exploitation. All right. Anyways, so fewer A's, A+, and A's, but more B's, C's, and D's, and also more E's than Baby Shell, which is a very interesting sort of spread. Let's see. If you look at it in a different way, you can see, a lot more grades clustered around this sort of 70% score. Baby Shell was much more spread out. So the lower 25th percentile and the higher 25th percentile were at 30% and 100%. And here we're at 40 something and at 80 something or 90 something. Another view of it, the stacked grade chart, the median was a low B, and then there were more E's than in Baby Shell, but kind of a more smooth, difficulty progression. I'm not quite sure what to think about that. Anyways, all right. This is the current state of the class in terms of grades. It's kind of the almost typical pwn.college fork. 1, 2, 3. So the biggest 3 grades are always A+, A, and then E. This is roughly a third of the class failing. We don't like that. We're a third of the way into the semester. So it's time to at least give some breathing room for a curve. So I added a small curve for now, 1% to every spread, every grade range. So A is down to 89, then B is 11% below that, 78, and so on, which makes things look a little better. So now there's more A's than E's. I like to see that. Last year, we ended up with a pretty heavy curve. Based on the progression this year, I don't expect the curve to be as significant. On the other hand, last year I realized that I curved the grades after taking extra credit into account, which isn't quite what you're probably supposed to do. So this year we'll do a curve. This is all before extra credit. We actually haven't added extra credit capabilities into our gradebook yet, but I'll do the curve pre-extra credit and then we'll apply extra credit. Pluses, yeah, A pluses are never curved. I don't think that this year I'm going to have other plus and minuses of other grades. If you feel strongly, let me know. I just, I think it's just fine to have A pluses and then all the rest of normal grades. But if you are at 98.6, then you're so close to an A plus. All right, let's see. Yeah, 98.95. That's an A plus in the bag. I expect to see A plus from you. All right, and thus let's launch reverse engineering. So we're gonna launch 2 modules. Embryo GDB is there to force you to get familiar with GDB. Embryo GDB was written by the top performer last year. Let's pull up last year's scoreboard. It's at the old instance. This is FreakMod last year. And then FreakMod went on to join our research lab, which is great, but also create Embryo GDB so that you all can get familiar with GDB and be GDB pros, which will help you reverse. And then, like I said, a revamped baby rev to teach you binary code. Both are due 9/28. All right. That brings our full set of due dates to this. All of the other modules, of course, you can still solve them for partial credit. 75% in the case of Embryo.io, because there's just a lot of them, more than I had expected I would create, and then 50% for the other ones. Then the 2 new ones due on the 28th. All right. So let's see. For reverse engineering, you will need reverse engineering tools, as I discussed in the lectures. Now, there are a lot of these tools, and they change all the time. Last year, our kind of chosen tool was Binary Ninja Cloud. You could just click on Open in Binary Ninja Cloud on all of the challenges. You can still use Binary Ninja Cloud this year. Just go to cloud.binary.ninja and upload the challenge to it. With the new interface, it's just we haven't gotten around to re-adding that button. Excuse me. There are many different tools available of these, right? You have Binary Ninja Cloud, which we used last year. It's kind of the commercial upstart, the underdog to IDA Pro, which is the industry standard, which also now has a free version of their tooling. So you can absolutely use IDA, and in fact, I will be using IDA in my demos today. There are open source reverse engineering tools for static reverse engineering. In order of the slides here, first one is Ghidra. It's the NSA's own reversing tool, so you can imagine it's pretty good, but they've open sourced it for you all to use. Well, not just you, but everybody. It's available here. Download it, install it. It's a Java application that runs on all sorts of different platforms. There is anger management from our own research lab here at ASU in collaboration with our many research partners. Anger management is a cutting edge research prototype. That also means it's a bleeding edge. You can cut yourself with it. There are features that may change radically day to day and week to week, but this is kind of the edge of reverse engineering. If you're interested in that, you can go to GitHub, go to releases. There's nightly releases. If you click on assets, there are portable runnable applications for all of the different well, not all of it, but many different platforms: Mac OS, Ubuntu, and Windows. Cool. And there is also Cutter Cutter is another open source binary reverse engineering analysis toolkit. You're welcome to use any of these. If you take a look at the interfaces, I mean, they're all actually very, 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 very similar, right? They all have some sort of a graph view of the disassembly. They all have some sort of a decompilation capability. They all have a list of functions on the left, right? This is Binary Ninja. This is Cutter. This is IDA. This is Ghidra. This is anger management. So you'll be able to collaborate with people using different tooling, etc., etc. Where they differ: quality of decompilation, quality of reverse engineering. But on these challenges, they're not quality on disassembly. I meant like actually showing you layouts of all the functions. On these challenges aren't advanced enough to really stress these tools. Quality of type recovery, stuff like that. But one sec, let me blow my nose. I'll be right back. So, question of which one do I recommend? I'm always 1 week out from recommending anger management because that's, of course, the one we work on. But I'm also nervous to have you use, very, very rapidly in development research prototype. Last year, like I said, we were using Binary Ninja predominantly. The year before, we were using Ghidra predominantly. The year before that, we were using ObjDump. Like, ObjDump is good enough to tackle many of these challenges. But honestly, I'm going to be demoing on IDA Free. IDA Free is sufficient for everything that you'll need in this class. You can, again, go hexrace.com/IDA Free. They have version for Windows, Mac OS, and Linux. So it's only usable really on 64-bit x86 binaries, but luckily that's what we're using. IDA paid version, of course, does much more, but it costs thousands and thousands of dollars a year for the license. And people pay it, so think about what that means about its quality. All right. Does IDA support MIPS? Yeah, no one is perfect. IDA does support MIPS. All right, so with this, we're going to do two things. That's the end of the slides. So what's going to happen right now is Connor will launch the chals, and then I will do a quick run through of GDB, as you'll need for the embryo GDB module, and then I'll do a quick run through of using IDA to reverse stuff, and we'll go from there. So let's see the chals. Just keep refreshing until either the thing crashes or the chals are launched. Damn. Something went wrong. Connor's dead. All right. In the meantime, let's talk about GDB. So, I'm going to create a directory. Actually, let's clear yesterday's. Okay. Let's create a program that we're going to reverse in GDB and then reverse in IDA. And we'll see kind of the difference. It's going to be a very simple crack me. That's going to take an argument. That'll be the password. Ooh, Connor. Okay, the chals are launched. Let's keep going with this. Of course, those that are very chal focused will jump on the chals, but we're gonna go through this and then look at the chals. 4 solves already on the first GDB. Yeah. GDB, embryo GDB is not meant to be hard. It's meant to be to ensure that when you ask us what's going wrong with my attempted solution, and we ask, have you looked in GDB at what's going wrong, you can have confidence that that is not hard to do. All right. So, and then Connor said he would highly recommend you read the GDB challenge output. All right. So, we check that to make sure argc is greater than 1. So we passed in, got our password passed in, and then let's check if the password is hunter2, and if it is, strcomp will return 0, and we will write out the flag. All right, boom. This is nice and simple. Let's include some stuff. I used to never include anything, but you know, the first couple of times you get really screwed by that. When you don't include a function, GCC assumes it's all good, that it'll show up later, and that function just takes 4-byte integers for every argument. And if you try to pass a 8-byte integer into it, all hell breaks loose because it gets truncated. So now I always include everything. All right, and then else we'll just print f incorrect. Puts it. All right, nice simple crack me that takes a password of hunter2. Takes pointer from integer without a cost. All right, here we go. No password, wrong password, right password. All right. So several ways to solve this challenge. One is strings. Right, strings is a program that'll just tell you all of the printable strings in the binary. Here's incorrect from that puts. Here's /flag, that argument to open. Here's hunter2, our password. Cool. That's obviously for very trivial stuff. Let's talk about GDB. So we run the program in GDB. Of course, we can run it and give it some arguments. We can redirect some standard out, whatever file into it. This didn't work because there's no such FDC, but let's say we can redirect its own source code as this is over standard input, just showing you that it can be done for challenges that take input over standard in. But we run it with an argument. It tells us it's incorrect. What can we do? Well, first, we can use start to start the program and dump us into a debugger in main, right? Debugging in main is starting debugging from main is a kind of a typical practice, not fully correct at the end of the day. That and I'll talk about this later. But we can do disass to disassemble, and then here is our and this looks familiar, right? You remember that I asserted something. Well, here's that assert failure. Here's that strcomp. Here's that open. Here's that send file. All right, and then we can set a this is GDB with no bells and whistles. Of course, in pwn.college, we have GDB, different GDB plugins that you can use to make things a lot prettier. But I'll set up a display of 4 instructions after my current instruction pointer, and then I can just walk through the code and watch me walk through this code. And so I can see it's jumping somewhere, and then it's doing a stir comp. All right, we keep stepping. I was using step instruction, which I will actually step into function calls. You can also use, let's actually start over. Okay, we started over. You can use next instruction, which will step over function calls, keep you in this function. So here we call stir comp. All right, we're after stir comp. We test the result of stir comp. We jump if that is not equal to main plus 132. Boom, it wasn't equal. Right, and of course stir comp returns 0. We check that return value against 0, and that was the JNE. All right, and so now we're going to call puts to tell us we're incorrect. Boom, and it did in fact print incorrect, and we're stepping through. We step through leave. We step through ret. Now, what does this do? If you recall, in the function frame lecture, there is every function has a frame on the stack. It sets it up by pushing the base pointer to the beginning of that frame and then moving the stack pointer left. I'm mirrored on the video. Left to create space for the stack frame. So this can be undone with move RSP, RBP, pop RBP to move the stack frame back, the stack pointer back to the right, and then pop the old frame pointer off, making the restoring the previous stack frame. Leave does the same thing. Leave cleans up the stack frame, and then ret of course returns from main. And if we step through ret, we're back in libc start main, which if you recall from the embryo IO modules is how main gets called. Cool. All right, so let's restart it, and then we'll see how to actually solve it. We can step, or next instruction, all the way up to stir comp. And here we can look at registers. So let's print out RDI, the first argument to stir comp, RSI, the second argument to stir comp. Both of these are pointers. If we examine them as strings, we see our ASDF command. Of course, when you just do start with no arguments, it keeps the last arguments from your R command. So R with some command line arguments sets those, and then start redoes them. There's a question on Twitch if this is recorded. Yes, Twitch records everything. We'll post the VOD to YouTube afterwards. All right. Or you can view it on Twitch afterwards. So we can also see the second command, and this is that secret password that we've been comparing against, and boom, we've solved this crack me with GDB. All right, that was a little bit of a pain in the ass because we stepped until stir comp was called. What else can we do? We can also say, hey, just break directly on stir comp. All right, now we just run, and here we are in stir comp. So you might not want to be in stir comp. You might want to break before stir comp. I'll show you how to do that before. We're in the stir comp call. How can we tell where we actually call this from? There are two ways. You can do where. It'll give you the stack trace. So we called from this 55521B. If we disass main, and we look at this 21B, that is the instruction right after the call. So of course this is what this is. It looks at the return value on the stack, and that's how it knows where we called from. So we called from the instruction right before this, but this is the call stack. So main is calling stir comp and an optimized version of strcomp that uses all of our fancy processor features to be faster. You can see it's using some crazy, wild, extended registers. Let's not worry about it. What we can worry about it here, now that we're at strcomp, is, of course, again, look at the second argument, and here it is. So we break at strcomp, run, boom. We don't even have to single step to it. If you wanted to look around, you can look around. You can print out 8 giant words in hex. So giant has 8 bytes. So this will print out 64 bytes of 8 words at a time from the top of the stack. Here's that return address into main, because this function just started, right? And all of this, of course, does the endian correction for you. We can say, hey, actually, print those 64 bytes out 1 byte at a time in hex. So here is that first 8 bytes without endian correctness. So this is stored in little endian in memory, 1 byte at a time, of course. 1B5255. Here it is, 1B5255. Very cool stuff. Okay, so we looked at how to dump registers, how to read memory we can, of course, read memory directly with an address. Boom. What we haven't looked at is how to break at specific addresses that aren't functions. So before I did break strcomp, and we actually ended up inside strcomp. First of all, how do we get the hell out of here? Let's say I want to actually look at what's going on after strcomp. What's strcomp returned? There are 2 ways. I braked at strcomp. I can do finish. This is a GDB shortcut that puts a breakpoint at the return address of this guy. So at the instruction right after the strcomp call, and goes there. Boom. Nice and simple. Now we're after the strcomp call. The other way I could do this is break directly where I want to break. So I can disable breakpoint 4, which was my breakpoint in main. You can do info break here, and you can see I disabled this. This is in strcomp. And I want to break right here at the call to strcomp. Do break. Boom. I put this this asterisk to tell GDB, hey, this is not a symbol. Don't try to resolve where strcomp is. This is an address. Just put a breakpoint directly there, and I run. And boom, I am at the strcomp call. Of course, no registers are changed except for RIP by a call. syscall and RSP, I guess, technically. So we can still see it right here. And if I do a step instruction, I'll be inside strcomp. I can do a finish, or this is inside the strcomp procedure linking table, the strcomp entry of the procedure linking table. If I keep stepping, now I'm in strcomp. This is how symbol resolution happens. You can there's a reference I have in the ELF loading module lecture from Program.io where you can dig deeply into this if you're interested. Right now, it's not important. All right, how do I get out of strcomp again? Finish. I'm back in main. If I finish here, yeah, it doesn't like GDB won't let you finish from main. All right. People have noticed that I have Intel syntax here, and normally GDB will incorrectly, of course, disassemble as AT&T syntax. This is the most important thing I'll teach you. Set disassembly flavor Intel. That's how you get the type of output I have. How did I have it already? I have a little GDB init that has some useful things. First, set history save on will create a .gdb history in the current working directory that has your GDB history. Highly recommended. It makes things much more usable. Set follow fork mode. When a process forks, GDB stays attached either only to its parent or only to its child. I don't think this is important for this one. I have it on parent. Right now, there are different cases. Sometimes you want to debug the child. For example, consider baby shell level 13. You could debug that in GDB and Baby Shell level 13 forks, and both are important. So you could follow either one. This is important. The base. My binary that I compiled. My binary that I compiled is position independent. If I well, that's not nice. If I run it in reality, how do I run it and have it? Yes. No. Can't. Okay, the point is, if I run this, just like libc and so forth, it'll get loaded at some random address. GDB disables that. So if I, of course, break main another way, the exact same thing. When I do break main, it says, hey, I broke at this crazy little address. That's the offset in the file of main. If I do a run, you can see this crazy little address ends up actually being added to something very large. GDB's default base that it adds is this 555540. It makes it much easier to actually save it as a variable, so then you can do stuff like easier use address offsets from your static reverse engineering tools like IDA in GDB, which I'll do in a second. All right. So let's check in real quick on the scoreboard. That is going to be your initial GDB crash course. This should be enough to have you intelligently approach Embryo GDB. As Connor said in the chat, make sure to read everything that Embryo GDB writes out to you. There's a lot of good hints into using GDB, and using GDB will pay off significantly in the solutions for these challenges. All right, GDB, so dynamic debugging and static or dynamic reverse engineering through GDB, static reverse engineering through IDA and the like, they're your left and right fists. You don't want to be fighting with one fist against these challenges. You want both fists. All right. So let's check in on the scoreboard. Oh shit, we're 10 minutes from the end of class. We're going to go over a little bit, guys. Sorry. All right. The scoreboard. Bubi is top number 1, followed by Amun-Ra, followed by Trees, Al-A, and Genesis. This is quite a race. Very exciting stuff. Let's see. These are 5 levels in, right? I'm not logged in. Good. I have to be careful clicking, because if I'm logged in as an admin, I'll like show people's email addresses and stuff. Yeah, 5 levels into Embryo GDB. Awesome stuff. Keep pushing. This is great stuff. Remember, GDB. GDB. We should have a chant, you know, GDB. GDB. Okay. Cool. Yes, Baby Jan is proud of you. Oh, I didn't know I could click on him without. Is it possible to set up pwn in pwn.college? So in pwn.college, there are 2 GDB extensions already installed. Jeff or Gef, I don't know how to pronounce that one, and pwn-debug. Do you really want beta? I don't know. I'm not against it. And then there's a question. If you installed pwn-debug, how do you go back to vanilla GDB? Edit your .gdb init file in your home directory. Yeah. Ooh, there was an upset in first place. Nope. Oh, wow. Blowing through them fast. Okay, great stuff. So, let's jump back to here, and then let's take a look at that same binary in IDA. Let me open it up, and then we'll go from there. kind of works. All right. So, oh, you can't see the pop-ups that IDA gives. All right, I'm loading this file, all default options within IDA. Here it is. God damn it, IDA. Why would you change the size of the screen? There we go. Perfect. All right, so here is IDA as I open the, this is the free version. You can download it, run it. I just opened the challenge, and you can see right away what was a little harder to see in GDB in that disassemble mode. If you hit space in this viewpoint, you see something very similar to the disassembly in GDB, right? Just a linear disassembly with a couple of more, arrows where the jumps happen and so forth. You can hit space, and here you are in a nice graph view. Okay, highly recommend going to options, general. You can't see this, but if you click on, they changed this. The fuck? No. Options, general, graph. Haven't used this version of IDA yet. I tend to stick with ancient versions until it becomes critical to upgrade. Okay, line prefixes turned on the relative offset from main. That's not what we want. Oh, there we go. Disable function offsets if you accidentally enabled it. Boom. Okay. Oops. You can also drag these around and fuck up the graph layout if you really want to. Okay. So, if you enable the address offsets, this becomes a lot nicer. You can take these addresses now. You can see, okay, here we have a program that starts out, compares something against the number 1, jumps if it's greater, and you can see whether this jump is taken or not is denoted by the color. If this jump is taken, the color is green. If the jump won't be taken, that branch is red. It's very tough for people that are colorblind like me, but it's not too bad. All right, let's see. Let me catch up on GDB. People are asking if you need IDA Pro. For these challenges, you really don't need IDA Pro. And okay, cool. IDA free is fine. Or if you're interested, check out the other ones. Ghidra is fully free. There's no Ghidra Pro. I mean, I guess there probably is a Ghidra Pro, but you have to like work for the NSA. But Ghidra free is perfectly capable and does everything IDA Pro does, just a little bit differently. For example, Ghidra has a primary view that is more like this. That is the linear view than the graph view. But it does have a graph view. Yeah. So, okay. So you can see, you can start reversing this manually. It checks for something and it says if it's greater than 1, does one thing, or less than it does another. Here it does something and calls strcomp and then tests the result. And we've seen all of this in GDB. And you can see it very easily. Boom, here's the password right in IDA. Or you can also see here is the offset of where the password is loaded. If this password wasn't in plain text but was computed somehow, and we could highlight this, copy this 120C, the offset in the file of this instruction, go back into GDB, and we could break. Let's disable breakpoint 1 and for break, and we could break at the address base plus that. Excuse me. Run. Oops. Run with an argument, and we're at our breakpoint where we're about to load whatever address this is, and we can see it's here. We can dump the string. Oh, no. That's interesting. Can't access. Why would it mean want to access? Oh, sorry. Okay, I did a very funny thing. For breakpoints, you need to put this star here to tell it it's not a symbol. Here, you don't. Here, what I tried to do, this is Hunter 2, what I tried to do is dereference the ASCII of Hunter 2 as an address. Here's 68, that's the H, 75 is the U, 6E is the N, 74 is the T. Awesome stuff. All right, so anyways, here is Hunter 2 right out of the binary. If you switch back to IDA, I don't have a hotkey for switching to IDA on my stream deck, but that's okay. If you switch back to IDA, and we IDA named this thing S2, it just created a happy name for, double click here, it'll take us to this view into the read-only data section of the program where it named this guy S2, which is this Hunter 2. We can rename it and say instead of S2, let's name this the password. Okay, now this is renamed. If you hit escape to go back to where we were reversing, we can actually name these variables. We can also right click and say, actually, don't show this as a variable, show this as, we do undefined, oh God. And now we fucked it all up. Does IDA free support undo? Oh no. Yes, it does, okay. For the longest time, IDA didn't support undo. Now, IDA does support undo, so you can hit Control-Z to undo. All right, not undefined. Undefined undefines everything. Where the hell is... I guess you can't. You can... Undefined operand. Nope. This is what I get jumping between these tools too much. Oh well. Okay. So a couple of other things that are useful in reversing. Let's say if you're looking, we found this, for example, in memory or in the binary, and we want to know who uses this, like where's this referenced in the program. We can hit X, and it'll show you all of the references to a specific object, in this case, to this specific string at this specific memory location. The only reference is where it gets loaded in main. We can double click here, and here we see this load effective address of the flag, similar to a lot of your shellcode. All right, that's super useful. So again, enabling this address display in the graph in the general settings, or you can always hit space to see it in the linear view. It's always here in the linear view. Double clicking to follow, you can double click on strcomp. This is that PLT entry of strcomp. You can double click on this flag to go to this, escape to go back, X to see the different references. What else can you do? Well, you can do this magical thing called decompilation. You can hit tab, and it warns you that, hey, IDA Free actually uses a web service for decompilation. That's okay, we don't mind. Boom, here is the decompiled version of the compiled version of our program. All right, so the decompilation is not perfect, as I discussed in the lectures. This is our best approximation of what was going on. There are many ways to produce this. For example, if you remember the original source code, I didn't use bang, I used equals 0. Technically, that's different, but here we are. But semantically, it's the same. So this is valid. The same thing works here. You can double click to go. You can double click on assert fail to go into the assert fail function, etc., right? You can hit X to see where certain things are referenced. and so on. Just like I hit N to rename this, you know, I'll say correct password. I can do that here. I can do it in the disassembly. Well, here it's resolved the string, but I could. This is a little too simple to show this off, but I could rename, let's say, strcomp to ASDF. I don't know. You don't want to do that, but if you don't have the symbol to know that that's strcomp, which in later levels you won't, that is very useful. You can also, as you try to understand things both here and in the disassembly view, you can create comments by hitting /. All right. So you can create a comment. You can create a comment in this view as well by hitting semicolon. So comments in both places. And you can create types. Let me... Connor's talking shit about == 0 versus the bang for strcomp. I absolutely disagree. I really fucked that up. Let's just undo all of this stuff. There we go. This looks like semantically I'm saying if it is not equal. But of course what I'm saying is if it's equal. So you should do == 0 because the bang implies in your mind not equal. Anyways, if it's not strcomp, right? You might think if it's not the strings aren't equivalent. Anyways, all right. So this is the very, very initial introduction into IDA. What is missing is types. Let me write a quick program that has types, and then I will show you how to reverse those types. And that'll be it. So let's copy a.c into t.c. And here, let's actually create a struct. Struct ASDF, which will have entered password. It'll have correct password. It'll have, or let's say desired password, and then it'll have was correct, and it'll have the flag. And here, actually, let's just create a global variable with this. And here, instead of having local variables, we'll say strcomp global state dot entered password of argv1 128. All right, and the same thing we'll just put here, enter 2. Okay, so we set this up, then we compared our struct, or we compare our passwords in our struct. If they're equal, we set the flag to, this is going to be ugly. We're going to read from the flag FD into this buffer 128 characters. And then otherwise, we will instead strcomp into this buffer incorrect, or strcopy. My bad. I'm sure someone on Twitch corrected me. Thank you for that correction too. Desired password. Desired password. Okay, boom. And then we will put global state dot the flag. We have ASD was correct equals 1. This won't be used, but that's okay. Equals 0. All right. Awesome. What doesn't it like? Stir copy. And this should be global state. And this should be global state. And this. Boom. All right. Works the same way. If we give it something wrong, it's wrong. If we give it something right, it gives us the flag. Amazing. Okay. Let's take a look in IDA. So, we switch back to IDA. We open. Don't save the database. No, why? Why does it do this? Why does it resize itself all over my face? All right, here we are. This looks very similar, right? Like the same sort of stuff here. If you hit tab, we see something a little bit ugly, but actually not as ugly as let me give you the worst case ugliness here. One sec. Let's fix this up. So it's not a global state. We're gonna have chal and main in 2 different functions. Main will set everything up and then call chal, passing a global state, but it'll instead create a global state here, initialize it all to 0, and then we'll pass it in here. And then chal will take a global state pointer. All right, this will look ugly as hell. Now everything needs to be dereferences. All right, so now we have our global state is actually in main stack frame, and we pass it into ASDF as an argument. And here. Boom. Chal is a void. Boom. Okay. Let's reopen this in IDA. And it's going to resize. Stupid IDA. All right. Here we go. All right. So now this is going to look much crazier. Here's the decompilation of main. Right? We do our assert. We set this buffer on the stack. So of course in the compilation process, the type information was lost. So IDA thinks, hey, this is a gigantic stack buffer. We set it all to 0. We copy something into part of it, copy something into some offset of it. So we do dest, take the 128th offset. Of course, that's skipping the entered password and into the correct password string. And then we take the address of that. So this is ugly, right? And then we go into chal and all hell breaks loose now. Now this is complete insanity. It doesn't know, because the type information is gone, it doesn't know what the global state struct is. It just gets some number. And here it's just doing offset operations on this number blindly, casting it to pointers and dereferencing that, right? It looks bad news. So we want to fix it, right? So let's fix it. Let's tell IDA that, hey, actually, this is a type How do we do it? How I'm about to do it is probably outdated because, of course, I'm used to much older versions of IDA. So let's go into the type view. No. Let's go into the, oh, my bad, wrong view. Into the local type view. Okay, so here are the types that we have. Let's create a new type, and then let's create a declaration of it. Right. So we know that there are 368 384 based on that length of the memcomp of the memset 0 in main bytes in here. You can't see the damn. All right, so I'm just typing out a struct ASDF that basically just has char something with 384 bytes in it. Here it is. That's what I typed. All right. And here we created a type ASDF. Let's go back to the view, decompilation view, and say in chal, and say, hey, set this. You can hit Y. You can't see any of the windows. That's not good. Well, this just brings up a copy of this guy, and I can do struct /ASDF pointer, hit OK. And it updates this. Now this is of type struct ASDF pointer. And this starting to look better. Instead of insane various casts and so forth. Now it's a dereference. We name this state, which is named global state in the original source code. It looks reasonable, right? So we are comparing something at 128, that's our desired password, against something at 0. So now, with strcomp. So here, we can say, okay, now this is thinking in our minds, this has to be a 128 byte long string, or less, and this is going to be a 128 byte long string, or at least something that's probably the same length. So let's take a gamble and go back to our local types view, double click on, no, I hate this view, right click on this, hit edit. It brings up a very nice menu, but let's see, I'm just gonna switch you manually to IDA's different hold on, I think I have to do this to refresh it. Yes, here you go. That, this is gonna be a disaster. All right, this is the Destruct Editor. I'm now going to say, okay, I know that there is string 1, that's 128 bytes. There is string 2, that's 128 bytes. And then there's some padding up to 384 bytes. And what is that size? 384 minus 256, 128. That's weird. Okay, anyways, we'll deal with that later. All right, so is that really? Yeah, okay. So this is what I said okay here. Now that disappeared. Let me find IDA again. Oh my God. Of course, we zoomed in, so now it's bad news. Oh my God. We have to figure out a way to make this less painful. All right, cool. So now we have our thing updated here. Let's go back into the pseudocode view. And now here's string 1 and string 2, and we can rename this. Right? We can say some string, other string. I misspelled padding. But here we see, okay, this is interesting. There's 4 bytes of padding that's unaccounted for. So this is means take the padding element and do an offset of 4 bytes So 4 bytes into the padding is another string that we're stir copying in. And here, this, the type of padding is obviously a D word. So we know another, do I want to do this? Well, let's try. We can change this directly here. I hit Y, which brings up this. Okay, that didn't work. Gonna have to figure out a better solution. All right, hit Y, that brings up this. So I'm gonna change char padding 128 to just int is correct, because you can see from the disassembly it sets it to, I'll just do some int. And then we'll do something better. All right, we hit int, some int. And it didn't change its name, so now I have to change its name. You just change this type. All right. So let's take a look at what happened to my type in IDA. Boom, we're back. So now this is much nicer. But we have int sum int equals 1. That's nice. This is our, obviously our flag based on this comparison of the password. So now you can say, okay, hey, I realize this is the password. This is the password correct flag. This is password 1. We're not sure which one is which right now. Password 2, right? But now this all makes sense because we added good types. Now there's just this ugliness. What the hell is this? This gets a dereferenced, gets the integer field password correct, dereferences it, makes a reference to it, resulting in an integer pointer, adds 1, which is pointer arithmetic to go 4 bytes over, and then reads 128 bytes into that. And then in the other use of it, it gets it as a char pointer, adds 4, same offset, 4 bytes, that's 1 D word, and writes incorrect to it. So obviously this is a 128 byte string at the end of our type that we accidentally eliminated. So I'm just going to right click on this, hit edit real quick. I won't do all of the window shuffling because that's just error prone. So some string 128 is here. Hit OK. Go back to the pseudocode. And when that gets updated, boom, almost the same as our original code. It's beautiful, right? Password 1, password 2, some string, password correct. This I can see is our output, which will have our flag here. Awesome. I can also rename these temporary variables. This is our flag FD, and by hitting N. Yeah, that's good stuff. I can change this. Say, hey, make it show it to me in decimal instead of in hex, stuff like that. Or if I can say show it to me as a character, for example, if it was a character. But hex is probably most useful. All right. So this is beautiful now. Now the only question is, what the hell is password 1, password 2? Well, let's see where they're used, right? You can hover over this, hit X. Ah, fuck, you didn't see it before. Oh my God. Let me show you where. This is when I hit X, it brings up the list of references, both read references and write references to that structure. There's only one right now. And that one is just the one in this this function, because IDA doesn't yet know where that main also uses this structure. So if we go back to main, you can see that this dest structure is still being interpreted as a character array, and then it's cast into this struct ASDF. So then we can say, hey, we can hit Y, which brings up this this please define a new type. And no, what did I just do? Oh my God, what did I just do? All right, guys, I'm going to find a better way to... All right, boom. That's a much better way of... Okay. Anyways, I'm in that little view. I'm gonna put struct ASDF star. I hit OK, and it updates it to we fucked it up. So it's not struct ASDF star. Because struct ASDF star is not a 384 size thing. That pointer is 8 bytes, so it's actually the actual struct, right? And I fucked it up. Okay, we're back. Let's undo what I just did. Okay, so I change it to struct ASDF. And it complains about sizes different. Boom. And here we go. So this seems to be incorrect because the output is only 128. Why is it telling me it's 132? Interesting. All right, the point is over here we see 388. So it should be 388 bytes in size. Is it? Is that what we see? Look at the types. Size, no, it's bigger than that. All right, we won't worry about it. What we will worry about is here's password 2. So this is obviously our password. This is obviously the hard-coded password. And we're done. We've reversed everything. We know everything in this program. And it looks good and understandable because we created a type to track it. So you will need this for the later reversing levels because the types there are very, very important. All right. Yeah, Connor, you're right. For some reason, it was including my canary, but we don't have time to dive into all of that. I think it'll be good. All right. So, any questions on anything? I guess we're half an hour over, so people are starting to cycle out anyways. But here today was a crash course in GDB and a crash course in IDA. But the same thing I did in IDA is doable in basically any reversing tool. Like I said, they're all almost the same. Cool. All right. Thank you very much for watching. So today's Thursday. The next office hours will likely be on Monday. Go dive in. Let's take a quick last look at the scoreboard. Whew. UV is at 262, which is through level 7 of Baby Rev. So you can see, one other thing. Baby Rev is a little different in that there are multiple challenges per level. So you can see level 7.0, 7.1, or 1.0, etc. The .0 is usually a teaching level. It's a level with extra output that guides you through its own solution. All of these past ones that you've tackled so far have all been teaching levels. Then .1, they're testing levels. For example, they won't have symbols. You won't know what each function does. IDA will name it after the address at which it resides. And then you'll need to rename it and develop that knowledge over time. At least in the later levels. So yeah. And then some levels have multiple testings. I don't know if in this module, kind of remind me. By the numbers, doesn't look like it. But later, some levels might have multiple testing iterations that are all slightly different. Cool. All right. Good luck. Have fun. Don't forget to ask questions on Discord. The help channels have been great so far. I'll create help channels for GDB and the reversing modules. And good luck. See you next week.